Hi, everyone. This one is the voice PowerPoint for the trajectory of the research designs. And we talked about this some at the very beginning of the course, that your question and where you want to start with your science really depends on where the state of the science is for that particular topic. So if not much is known about this topic or this problem or this population, you want to start with exploratory types of research and observational designs. So let's just walk through sort of the trajectory of what this might look like. When we're talking about exploratory research, we really want a systematic investigation of the relationship among two or more variables. So we may start with reviewing the literature and just understanding what the current state of the science is. And exploratory designs are used to predict the effect of one variable on another or test the relationships that are supported by clinical theory, or come up with diagnostic and prognostic factors that are identified through exploration of these relationships that exist between these variables. So these studies can be approached in a variety of different ways. And a prospective study, you recruit a sample, and you follow them forward in time. A retrospective study, you may go to the electronic health record or some large data set and look back retrospectively what happened. So you may compare those who did not have a good outcome from a particular condition and compared to those who did have a good outcome, and go back in time and see how the course may have differed. You also can have longitudinal research, which is studying that sample over a long period of time and looking at what happens. So because I'm a pediatric person, I think of things like developmental progression in children, and you follow the children throughout their first year of life and then annually and look at how the development goes over time. Then cross-sectional studies are a little more efficient, where you could examine everybody at the same time, but let's say get a 3-month-old cohort, a 6-month-old cohort, and a 9-month-old cohort, and look at what the developmental differences in those age groups would be. So the methods that can be used for these types of studies are correlational, predictive correlational, and you can do some theory testing using like a case control or a cohort study. So we'll talk a little bit more about this, but correlational is just looking at the relationship between two variables. Predictive correlational, on the other hand, might be something like, what are the strongest predictors? So in a study that I've just completed with a group at Children's, we looked at what are the strongest predictors of obesity in childhood cancer survivors. And the correlational might just be something like, what is the relationship between the severity of substance abuse in a parent and the child's health? So those are the kinds of variables that you might just look at in exploratory research. Theory testing with a case control might be finding a child the same age, the same gender, the same ethnicity, and have a comparison of one who gets the treatment and one who does not. Cohort studies, on the other hand, you may compare two different units. One unit gets some type of intervention and the other unit does not. So you want to evaluate causality in observational designs, and you want to rule out the influence of bias or confounding variables, chance, variation between the two groups, and assess the strength of this cause and effect relationship. So you might do that with a time sequence. You might look at the strength of the association using a relative risk or a risk ratio. And you want to know about the biological credibility. So does this make sense physiologically, biologically? And you want to compare the findings with other studies. Is it consistent or is it different? And is there a dose response relationship? All of those can be additional observational designs that help you explore the relationship between variables. So prospective research, we said, you would do a direct observation and record what's going on in the present and observe what factors precede an outcome. Retrospective examines the data that's already been collected in the past, and as I said before, you kind of go backwards and look at what happened that may have caused this outcome, both positive and negative. Longitudinal designs follow a cohort of participants over time. Cross-sectional, we usually have stratified groups of subjects at one point in time. So as I said, we may want to do a cohort of 3-month-old, 6-month-old, 9-month-old, or they can be age or generational differences. They could be cohorts by treatment, but you want to stratify, you get everybody at the same time, but you stratify by group. Correlation and prediction. So correlation is a measure of the degree of association among variables. Prediction, on the other hand, is designed to predict a behavior or response based on the observed relationship between that behavior and other variables. So here's an example of a research trajectory that kind of starts with the exploratory and moves its way up this, this design ladder. So I'm going to give you an example of some of the work that I've done. So I started my dissertation many years ago doing a qualitative descriptive study of school-based support groups for kids with addicted parents. And the kids, I interviewed kids, I interviewed counselors, I did focus groups, and I came up with a description of what these support groups look like and what the kids thought were the benefits of participation. Then we did a survey study, just asking kids who had a parent with a substance abuse problem what their needs were. And it was a needs assessment, just a survey. Then we did a descriptive study, just looking at the correlations, and we did some regression, just looking at what the severity of parental substance abuse and the kids' health was. Then we did a feasibility study. What would it look like if we tried to do a study and measure outcomes of participation in a school-based support group? Was it feasible to recruit kids? Was it feasible to get kids to come? Was it feasible to do the outcome measures? Just kind of feasibility. Then we did a pilot study with a control group, and we randomized to treatment and control, but it was just a pilot. Then you can do a randomized controlled trial with multiple sites. And then the next step is effectiveness. So in the real world, where people are trying to do this on their own, and they're trying to do it in various school settings, what does it take to reach all those kids? And you might use something like that RE-AIM framework that we've talked about before, with how many of the kids that should have gotten the intervention did you reach? What was the effectiveness when you did it in the real world? And what does it take to actually implement things in practice? Did people stick with it? Did they maintain it? Then applied research adds the utility, cost, benefit, and feasibility. And then after you have really solid data, you can move to quality improvement. And does this work in your setting? So in correlation coefficients, we're measuring the association between two variables. It's a calculation of a number representing the strength of a relationship. No causation is implied. We're just looking at, is there a relationship between these two? So correlation coefficients provide a measure of the strength and the direction of a relationship. And one thing that helps you also visualize this would be a scatter plot. And when you're working in SPSS, it will give you a scatter plot. So as we look at the first positive correlation scatter plot, we see that as the wife's age goes up along this axis, the husband's age goes up on this axis. And it's pretty much a direct positive correlation. Now this one's a negative correlation and it's not quite as strong. They're scattered out a little bit more. But this goes with the quality characteristics that they're measuring and the process input. So there's a negative correlation on this one, but as I said, they're scattered a little more, so it's not quite as strong. This one has no correlation whatsoever, and this is a nonlinear correlation. So they are correlated, but it's nonlinear. So as you look at the scatter plots, you notice the independent variables on the x-axis and the dependent variables on the y-axis. And then you look at the positive and negative correlation. So a positive correlation, as x increases, y increases. A negative correlation is x increases, y decreases. No correlation, they were scattered all over in that plot. There was no rhyme or reason, they were just scattered all over. Curvilinear suggests there is a relationship, but it's not positive or negative. The statistical tests you're going to do to look at correlation are the Pearson correlation coefficient and the Spearman correlation coefficient. Let's talk about Pearson first. Pearson is used for interval or ratio level data, and it requires a normal distribution of the variables. So if your data is real skewed, you don't want to use Pearson. The Spearman correlation measures a monotonic relationship. It's the same direction, but not linear. So it's considered a non-parametric test. It can be used with ordinal data, and it does not require the normal distribution. So it's not quite as powerful as Pearson, but it is a good measure to use if you have non-parametric data or you don't have normal distribution. So the first step is to state the hypothesis. And in the example I gave you earlier, the hypothesis was the severity of parental substance abuse will not affect the child of a substance abuser report of health problems. And the alternative hypothesis was the severity of the parent's substance abuse would be associated with the kid's health problems. So the next step is we use the Pearson correlation. We had normally distributed data, and we also had interval or ratio level data. So we defined the level of significance as alpha at 0.05. We made sure the data met the assumptions. So there were independent random samples, There were two measures to compare. There was normal distribution, interval or ratio level data. We reviewed the scatter plots, and it looked like linear relationships existed. So your strength and direction of relationship, the Pearson and the Spearman correlation coefficients are denoted by the R. And it denotes the direction and the strength of the relationship. So it can go from a -1 to a +1. -1 is a perfect inverse relationship, and +1 is a perfect positive relationship. And the closer to 0 is the weaker the relationship. Your R squared is your coefficient of determination, and that's the amount of variance in the dependent variable that is explained by the independent variable. So it's this little portion of overlap right here where our line points. So as we interpret the values that we get with correlation coefficients, whether it's the R or R squared, R plus or minus 0.1 is considered a weak relationship, a weak positive relationship, a weak negative relationship. R squared is equivalent to about 1% of the variance is shared. So again, a very weak relationship. There is some relationship there, but it's weak. A 0.3 is a moderate or a typical correlation. And the R squared tells you that 9% of the variance is shared between those two variables. A 0.5 is considered a strong or a substantial relationship between those variables. And it looks like about 25% of the variance is shared. So here's some examples of research questions that you might ask looking at these correlations and relationships this way. So is maternal weight correlated with a child's weight? And the answer is yes, it is. But that's something you could explore with correlation. Are patient satisfaction scores on a unit stable over time? So again, you could correlate those over time. Does social support correlate with less prematurity in minority populations? Does the neighborhood a child grows up in correlate with life expectancy? So those are just examples of research questions that you could use a correlation design. So what we did was that study I mentioned before. What is the relationship between the severity of parental substance abuse and the health of a child who has a substance abusing parent? And here's the correlation, the scatter plot that we got. So, you know, it's not perfect, but there appears to be a linear correlation. So after we saw that, we went ahead and did some more analysis. And first, we looked to see if there were differences between males and females. So the CAST is the Children of Alcoholics screening tool, and there are cut points. So we had 11 participants who fell in the low. They assessed their parents' substance abuse to be low. We had 35 that assessed their parents' substance abuse as moderate, and we had 75 kids who told us their parents' substance abuse was high. And there were more males that thought it was low and more females thought it was high, and the inverse of that is true. So there were significant differences in how males and females assessed their parents' substance abuse. There was not a difference between ages. So we had 14, 15, 16, 17-year-olds, and the p-value was greater than 0.05. So there were not differences by age, but there were differences in their perception by gender. And then ethnicity, the p-value was greater than 0.05. So we did not see differences in the severity by ethnicity, and we did not see differences by the number of substance abusers in the family. Then what we did was use another instrument that looked at the child's self-report of medical conditions, physical symptoms, negative mood, positive mood, health risk behaviors, self-confidence, activities with friends, activities with family, and social integration, how they got along with other people. And we looked at, were there differences in their self-report of these things by the level of their perception of their parents' substance abuse. So when we compared the report of medical conditions of stomach aches, headaches, backaches, just a variety of medical conditions, when we looked at the low CAS group, so they thought substance abuse in their family was low, compared to medium, compared to high, there were significant differences. And you can see these kids said about 1, these kids said almost 2, and these kids said 2.5. So there were significant differences. Same findings with physical symptoms, same findings with negative mood. The inverse of that was found with positive mood. So the kids with lower CAS scores had a higher positive mood, and the kids with high CAS scores had a lower positive mood. And then the other stuff, their health risk behaviors, their self-confidence, their activities with friends, family, and social integration, there were no significant differences. So think about an exploratory study design for your area of interest and how you might create a trajectory like this to look at your area of interest. And I look forward to talking with you next week as we move through the course.